All right, and welcome viewers. We've got space weather scenarios lighting up, so we decided to make a short video about that. Let's do it. Major solar flare happened here, right in the earthly facing zone. And that was an M4 class flare. And we've got relativistic particles and all kinds of other interesting stuff happening. So let's get to it. Starting out with these SDO views, allow me to exit the screen. The solar flare came from sunspot 2975, one of the larger, if not the largest sunspot of the solar cycle. There's another huge one down here. The likelihood of a major flare from that is still there as well. And let's show some more views here. There is an Earth-directed coronal mass ejection here. We can expect significant geomagnetic storm conditions in 2 to 3 days from that. Also, one of the highest speed radial bursts that we've seen at over 1,200 kilometers per second estimated speed. Here's the view zoomed way out to include the LASCO C3, which is the blue area, and the LASCO C2, which is the red area. The coronagraphs at Lagrange point 1 in between Earth and Sun. Also Mercury showing up there on the screen right. And you can see ejecta around most of the coronagraph there at some points throughout the CME. An indication that it is indeed earthly directed. Yes, it's quite dense. The majority of the plasma is, and the most dense portion is a bit north of planet Earth, but we expect a significant earthly impact from this very large coronal mass ejection. So here we'll zoom in a little bit farther. We saw some protons show up at Earth in only about 20 minutes, which means they were traveling at approximately 1/3 the speed of light. You can see all those little flecks on the red part of the LASCO C2 there. That is protons striking the instrument, folks. So there's a slightly more zoomed in view. And we'll zoom in a little bit farther. First, I'd invite you all to smashomash.com. Did you know we're writing a paper about solar sunspot cycles? Yeah, it's true. So help us out by clicking the links below the video. Thanks to everybody who's supported the channel over the past 4+ years. Lots of new chapters coming. We are not typecast to do anything. Consider becoming a member of the Smash team if you'd like to see the content continue to exist and remain publicly visible. If you want to find out about this stuff before anybody else, we posted to the Smash team quite quickly after it occurred. And there you can see a bunch of posts there at smashomash.com/smashteam. Peak flux was around 11:30 Universal Time. There it is. It was an M4 class flare. Another flare happening right here as we stream here. And it's another minor M class flare. So check it out. Once again, the sun coming through with activity while we stream. So just spectacular stuff going on here. We also saw radio blackouts over Western Africa and portions of the Central Atlantic Ocean. And check it out. Polar radio blackouts as we forecasted. Peak flux has already occurred here. It looks like peak flux was around, well, we'll get to peak flux in a minute. But that is a significant polar radio blackout, and we can expect that to continue to occur for a few days here, as that was quite a significant proton infusion. So not the highest density that you'll ever see, but one of the highest speeds, possibly the highest speed we've ever seen for the arrival of these relativistic particles. That's the absorption of the D region of the ionosphere. So we regularly show the ionosphere, the F region. And let me just go to my graphic here. So the D region, this is the portion of the ionosphere where radio signals typically are attenuated back down toward the Earth. However, when we get a solar flare like that, this opens up and radio signals just go out into space. And that's what we mean by deabsorption regions. Pretty crazy stuff, folks. Pretty crazy stuff. So here's the proton flux. And what's interesting about this is that, again, peak flux occurred around 11:30, and we saw particles already showing up around noon. So it looks like more like about 20 minutes there before we saw an uptick. I'm going to say 11:50 Protons already started showing up, since it takes about 8 minutes for photons to arrive from the sun. They travel at light speed. Those protons were traveling at about 33% the speed of light. Quite a high-speed series of relativistic particles currently in the earthly geospace. So just spectacular stuff going on. Thanks for leaving comments, everybody. Let me check on those and address them. Thanks for showing up and dropping us a line, Ms. Creighton and One Audio. Yes, it's a space weather blitzkrieg going on today. Exciting stuff. And another M flare just happened while we were making the video. Oh, a C9.8, I stand corrected. Thanks for that info, Ms. Creighton. Let's get back to the imagery here. We've got some more different zoom levels on the SDO and the LASCO C2 and C3, as well as that's a composite. The LASCO C3 is the blue, the LASCO C2 is the red, and the SDO AIA 131 angstroms, ionized iron, is the aqua color in the middle. We're going to get even closer here. Here is Sunspot 2975, producing quite an interesting flare indeed, folks. And you can even see the sudden impact there on the SDO. Right after the flare, you'll see it get kind of blurry. That is relativistic particles striking the SDO. So just spectacular imagery, an exciting day for space weather once again. And let's zoom in even closer. Let that play through one more time. Yowzers. And we'll zoom in even closer here. Here's the extreme close-up. It's going to look pretty blinding. And 131 angstroms and 94 are the two best wavelengths through which to view solar flares from the SDO. They take 10 images per minute instead of only 2 images per minute, so a 5 times higher temporal resolution there on those two wavelengths. We've got a couple more images of the sun here to show you. Again, we are expecting a significant geomagnetic storm from this one. Certainly some portion of the CME expected to strike the Earth's magnetosphere. I'm going to say a KP 6 to 7 from this. So we could see some power outages and so on, depending on what part of the Earth you're on, depending on what time of day it strikes. So, for example, if the CME strike, if it's noontime in a place that's using a lot of electrical power, a place that is very hot, for example, which is using a lot of air conditioning, more likely to have power grid down conditions. Also, third world nations without as much electronics in their power grid are more likely to have grid down conditions as a result of this. First world nations are a little bit better at shutting down their systems when there's too much induction. And we'll zoom back out to close out the video. We'll let that play through one more time at 94 angstroms. Yowzers. And there's our zoomed out view. That's the LASCO Soho, the Soho LASCO C3 on the right and the Stereo A coronagraph on the left. Spectacular series of events. And thanks everybody for tuning in. Congratulations on realizing that the channel exists. We'll have posted this one on all 3 major video sharing platforms that we use. It would be the Smash News Network posts videos to BitChute, to Twitch, which is where this was originally streamed live, as well as to YouTube. So if you're viewing any of those places, make sure you check out the other spots, as there's exclusive content on all the different places. Thanks for tuning in. May that solar wind be at your back. I've been your host, Dan, a.k.a. Smash-A-Mash, signing off from the Smash News Network, least busted name in news.